In this video, we will talk about another method of demonstrating the sample space, which is Venn diagrams. And again, if you look in the OpenStax Statistics book, this is section 3.5. And for the Lumen Introductory Statistics with Corequisite, that is in Module 3. A Venn diagram is a picture that represents the outcomes of an experiment in groups. It generally consists of a box, and the box represents the sample space. Inside the box are circles or ovals that represent events within the sample space. And every area is populated with the exact elements, or the number, or the percent of the elements that corresponds in each category. So, for example, if our sample space were the 12 numbers from 1 to 12, and the events were P is prime, which will consist of the prime numbers from 1 to 12, and these are 2, 3, 5, 7, and 11, so there is 5 of them. The event S, which is the numbers that are less than 7, and these will be the numbers 1, 2, 3, 4, 5, and 6. These are 6 of them. And D is the event, the number is odd and single digit. So odd and single digit numbers will be 1, 3, 5, 7, and 9. Then we have a sample space, so the numbers from 1 to 12 must be in this box. So this is our sample space. And then we have 3 events. Let's call the leftmost bubble P for prime. The one at the top right, let's call it S for 7, less than 7. And the other one will be D for odd number single digit. So we want to start placing the numbers wherever they belong. And we will start with the number 1. And the number 1 is in the event S and also in the event D. So it's less than 7, it is odd single digit, but it is not a prime number. So it has to be in S and D, but not in P. Now P is this circle or this bubble, and 1 cannot be in there, but it has to be in both S and D. So 1 gets placed in the little part of the intersection of the 2 bubbles S and D, but outside of the circle P. The next number is number 2. Number 2 is in all P, S, and nope, it's not in D. I'm lying. So it's in P and in S, but it's not in D. So it has to be within the circle for P, within the circle for S, but not in the circle for D. So we will place it in the common area, the intersection of P and S outside of D. The next element is the number 3, and the number 3 is in all 3 of them. So we will place it in the intersection of all 3 of them. Let me highlight this intersection with a blue. This is for numbers that are odd, single digit. They are also numbers less than 7, and they are also prime. They have all 3 categories. The next element is 4. 4 is a number less than 7, but not prime or odd. So it has to be inside the S bubble, but outside the other 2 bubbles, so 4 will go here. 5 is a prime, is less than 7, and it is an odd single digit, so it's in all 3 categories. It will go together with 3. The number 6 is less than 7, but not prime or odd, so 6 will go in the S bubble, but not inside any of the other 2 bubbles. The number 7 is a prime, and also an odd single digit, but it is not less than 7. So prime and odd single digit will go in the intersection of those two, but outside of S, the bubble S. The next number is 8, which is not a prime, not less than 7, and not an odd single digit. So 8 will come outside of all 3 bubbles, but within the sample space. 9 is an odd single digit number only. It's not a prime and it's not less than 7. So it's going to be inside the D bubble, but outside the other 2. The number 10 is neither a prime nor a number less than 7 nor an odd single digit. So it has to be within the sample space but outside of all the 3 events. The number 11 is a prime number only. It's not less than 7 and it's not an odd single digit number. So it's going to go inside the prime bubble but outside the other 2 bubbles. And finally 12 is neither of the 3 and it's going to go outside. So the concept here is that our sample space had 12 elements. So 12 elements. Our prime number set had 5 elements. Our less than 7 set had 6 elements. And the odd single digit set D had 5 elements. And none of them appear all together. So there is no place, there is no area in this Venn diagram that actually has 12 elements gathered together. 5 elements gathered together, 6 elements gathered together, or 5 elements gathered together. The way these numbers have been split, they are in areas that describe a characteristic of them. So they fall into a particular event or not, and they are grouped in mutually exclusive areas that have certain properties. So the number 11 is a prime that is not less than 7 or an odd single digit number. The number 10 is in the sample space, but it is not a prime. It is not less than 7, and also it is not a single digit odd number. The numbers 3 and 5 have all 3 properties. They are primes, they are less than 7, and they are odd single digit numbers. The number 9 is only an odd single digit number, but it is not a prime or less than 7, etc. However, the bubble for the primes, which is highlighted in yellow, actually does contain two, 3, 5, 7, and 11. Does contain the 5 elements that we were expecting it to contain. The bubble S does contain 6 elements. 1, 2, 3, 4, 5, and 6. The bubble D does contain 5 elements. 1, 3, 5, 7, and 9. And the whole sample space indeed contains all the numbers from 1 to 12. Another way that Venn diagrams can be helpful is to visualize a word problem. In this scenario, we have students at a local college, 40% of whom belong to a club and 50% work part-time. 5% of the students work part-time and belong to a club. So in this case, to visualize this, I'm going to draw the sample space, which is the whole college. And we have 2 categories, students who belong to a club, let's call them C, and students who work part-time, and let's call them PT. And they told us that 40% of the students belong to a club, so that's 0.4. and that 50% work part-time, and that will be 0.5. Now, I can't put those numbers in my Venn diagram because 0.4 is for the whole bubble for clubs, and 0.5 is for the whole bubble for part-times. And I don't know the individual percentages that will go into these three separate areas. However, they told us that 5% of the students work part-time and also belong to a club. So now that I know that, I think I'm gonna have to move these guys. Actually, let me just stretch them a little bit. Nice. And then let me try this one. All right, now that I know that in here I have 0.05, 5%, I now know the remaining areas for club and part-time. A total for club is 40%, and therefore the remaining, after 5%, is also in the part-time category. This will be 35%. And the total for part-time was 50%, but 5% of them are also in a club. Therefore, part-time not in a club will be 0.45 or 45%. So the next question now is, what is the rest of the college students? So the rest of the college students will be the remaining of those who are in a club or part-time. Club or part-time is 0.35 plus 0.05 plus 0.45. 35% belong in a club only, 45% are part-time only, and 5% are together. So that comes to be 0.85. Now there is another way to find this, and that was with the general addition rule, if you remember, which is algebraic, to say that this should equal the probability of club plus the probability of part-time minus the probability of both, because we double counted those. So that would have been 0.4 plus 0.5 minus 0.05. Correctly calculated earlier are 0.85. However, the 0.85 allows us to find how many students are not in a club and not part-time, which means how many are out here in the remaining sample space. And if 85% of your students are within the two bubbles, within the two events, then the remaining, which will be 15%, will be outside. So if somebody said, how many students are neither in the club nor work part-time, we will say that 15% of the students are in that group. What is the probability a student is in a club given they are part-time? And if you remember, the formula is probability in a club and part-time divided by the denominator of the event, which is to be part-time. Remember, the denominator of the event is what is the given condition. Now, club and part-time is the intersection, and we found it to be 0.05, or it was given to us. The probability of part-time is 0.5, and when you divide that, it is 10%. 0.1 would be the solution to that. Our last problem in the category of Venn diagrams is has to do with blood type. A person with blood type O and a negative Rh factor can donate blood to any person with any blood type. 4% of African Americans have type O blood, so that is 0.04 or 4%. Sorry, I didn't read the whole thing. they have type O blood and a negative Rh factor. So I guess I should have put the 0.04 in O blood and negative Rh factor. 5 to 10% of African Americans have the Rh factor. So let's say here we will put the median or the middle, the average. So let's say 0.075, which is 7.5%. And 51% have type O blood. So that will be 0.51. The O circle represents the African Americans with O blood, and the RH minus oval represents the African Americans with the RH minus factor. So we can actually complete the whole Venn diagram and be able to answer any kind of question that somebody could potentially ask us. So if the center, we always start from the center, if the center, which is the intersection between O and RH negative, is 4%, and the O bubble is 51%, then O without RH negative will be the difference, 0.51 minus 0.04, that will be 47%. And if we estimated that RH minus would be the class mark of 5 to 10%, so 7.5% minus 4%, this will result with RH negative but not blood type O being 3.5%. So we can find now the group that either has blood type O or have the factor, the negative factor, and we can find it two ways. One is from the Venn diagram to say 0.47 plus 0.04 plus 0.035, and that will be 0.545 or 54.5%. Or we could also do it as adding the 0.51, which is the probability of O, plus the 0.075, which is the probability of the negative factor, and subtracting the common ones that we double counted, the 0.04. And that would also be 0.545. Now, to describe the overlapping area, which would be the intersection of the two, that is the description given by the problem, that we have 4% of African Americans that have blood type O and also Rh negative factor. Describe the area in the rectangle but outside both circles. So that area would be, let's highlight it with a different color, outside of the events blood O and outside of the event Rh negative. So these are the rest of the African Americans. So this would be African Americans that don't have blood type O and also don't have the negative factor. So neither blood O and also not the negative factor. So in this last section of our probability OER statistics unit, we discussed tree diagrams and Venn diagrams.